Hey there. Ever wonder if AI is really thinking, or just playing a high-stakes game of guesswork? Today, we're diving into a groundbreaking study that's rewriting the rules of how we test AI reasoning. It's called Reimagine, and it's all about figuring out if these smart models can actually think, or if they're just good at memorizing answers. Let's start with the big question. Do AI models like GPT or Llama truly understand the problems they solve, or are they just picking up on patterns in the data they've seen? The answer isn't clear. Some say they mimic human logic, but others argue they're just relying on statistical magic, remembering what they've seen before. This study takes a fresh approach. Inspired by a concept called Pearl's ladder of causation, think, cause and effect thinking, the researchers built a framework called Reimagine to test AI across 3 levels of reasoning. Let's break it down. Level 1, observe. This is the basics, testing if AI can solve problems exactly as they're presented. Imagine a math quiz. If an AI gets the answer right, does it understand the logic, or did it just memorize the solution? Level 2, mutate. Now things get tricky. The researchers tweak the problems, changing numbers, swapping variables, or adding irrelevant details. If the AI still solves them, does it mean it's adapting, or is it still just guessing based on patterns? Level 3, imagine. This is where it really shines. Here the AI has to handle counterfactuals, scenarios like, what if the rules were different? For example, if the price of a muffin doubled, how would that affect sales? This tests whether the model can build new logic, not just repeat what it's seen. The magic of Reimagine is its pipeline. It translates problems into a symbolic format, then systematically alters them to create new challenges. Think of it like a recipe that's restructured, same ingredients but new steps. This ensures the AI can't just rely on memory, it has to reason. What did they find? When tested on math, coding, and logic problems, all the AI models showed some reliance on memorization. But as the tasks got more complex, especially at level 3, their performance dropped. This suggests that while AI is impressive, it's still far from human-like reasoning. Why does this matter? Well, if we're trusting AI to solve real-world problems, like medical diagnoses or legal decisions, we need to know if it's actually thinking. Reimagine gives us a clearer lens to evaluate that. Let's take a concrete example. Imagine this: Lee mows one lawn and charges $33. Last week he mowed 16 lawns, and 3 customers each gave him a $10 tip. How much did Lee earn? At first glance, you might calculate 16 times 33 plus 30. But here's the twist. What if the question secretly changes the rules? Like, assume Lee got paid in pounds instead of dollars, or he damaged the lawns and had to pay customers instead of getting tips. These tiny shifts test whether the AI is just crunching numbers, or actually understanding the logic. This is part of a bigger idea called symbolic benchmark synthesis, a way to create tricky problems that push AI to think deeper. The goal isn't just to solve equations, it's to spot distractors and hidden assumptions. For instance, one problem might say, Janet reads 80 pages a day, Belinda reads 30, but assume Belinda actually reads 50. The answer isn't just a calculation, it's about adjusting the numbers based on the new rule. Real-world problems are full of distractions. A model that can't separate key info from fluff isn't reliable. The research shows that even small changes, like swapping tips for damages or altering currencies, can trip up AI. It's like a puzzle where the answer hinges on what you choose to ignore as much as what you focus on. Here's the cool part. The study didn't just test AI on tricky problems. They gave models mutated examples, problems that had been tweaked, to see if that improved their performance. And guess what? When models saw both original and mutated examples together, they did way better than when they only saw one or the other. It's like studying with a mix of practice problems. You learn the patterns and how to spot tricks. But they took it even further. What if you combine multiple mutations? Like adding both a logic twist and irrelevant info. The models struggled even more. Their accuracy dropped, and the results became more unpredictable. It's like solving a puzzle with multiple moving parts. Each change adds a new layer of complexity. So what does this mean? These findings highlight how fragile AI reasoning can be. Small changes in how a problem is presented can create big hurdles. But they also show that with the right training, like mixing original and mutated examples, AI can get better at adapting. Next time you see an AI solving a math problem, remember, it's not just about the answer. It's about how well it can navigate the twists and turns of the question itself. And that's what makes this research so exciting, because it's pushing the boundaries of how we teach machines to think. Thanks for watching. If you want to dive deeper into the study or explore how AI reasoning is evolving, hit that subscribe button. Stay curious, and let's keep unraveling the mysteries of smart machines together.